Okay. So, people, welcome back. And sorry for this rather longish break on my part. Can you guys see me? Because I can't see you guys. I mean, I can't see myself basically. Obviously, I won't be able to see you guys.
Yes, yes, we can see you.
Hey, great, cool. Thank you. So, sorry about this rather longish break. Uh, as you probably know, situation was slightly beyond my control. The main thing is that we need to figure out how to make up for this time. So normally I don't like taking extra classes, and we have two options going forward. This time something needs to be done. Okay, otherwise I won't be able to cover the backlog. Too much of a disturbance has happened. So there are two things that one can do. One is that going forward, whatever topics are left, some of these topics, they are conceptual, and some of these are not that conceptual. Okay, they are more information heavy. Two or three topics are like that. So one possibility is that for those two or three topics, I create videos the way I was creating earlier, and then I give you guys those videos. Okay. And the other possibility is that we do some extra classes, and my guess is that we'll have to do about two, if not three, extra classes, and these will be like at least 2 hour long classes. Given that you guys are entirely booked on the weekdays, we'll have to do it on weekends. Okay. So I don't know. Let's see if we can use this stupid poll feature over here. So let's say I call it going forward. And option one is extra classes on SAT. Option two is extra classes recorded on, recorded. Okay. So, yeah. Can you guys see the poll?
Yes,
Yeah.
sir, we can see the board.
Uh-huh. Okay, maybe I think, yeah, you should not be seeing the result right away. You should be seeing it later. Okay, so there are 67 or so people. So I, uh,
People who
71.
have logged in using mobiles cannot answer the poll.
Okay, so people who have logged in using the mobile, please put it on the chat box. So I'll add it. Okay, so just say recording, or just say whatever extra class, or say Saturday, something like that. And then I'll add it over there. Oh, why am I not surprised? Yeah. Okay. What is no?
I mean, no recording.
Okay. Okay. Yeah. No, as expected. I mean, this. Okay, you guys can't see the results yet, no?
Not
Can
yet.
you? Not yet. Huh? Okay, so let it go for a few more minutes, and I'll create the results for you. I'll show the results to you guys. 3, 4, 5, 6, 7, 7, 1, 7, 2, 8, 2, 8, 3, 8, 4, 8, 5. Okay. So yeah, let's just go there. So I think now everybody should be able to see the results. So we have 55 plus 8, 63 votes on one side and 13 votes on the other side. Not 13, sorry, 12 plus 3, 15. 63 plus 15 should add up to 78. It has added up to 77, close enough. So anyway, so this is not very surprising. This is pretty much what I had thought the poll will lead to. So it's cool. So that's what we are going to do. Some of these classes will put on recording, and the remaining will do on live, and we'll try to avoid the extra classes. Only thing I'm saying is that in case there is a conceptual topic for which I really run out of time, I might have to take one at some point, not more than one. That much I can assure you. Okay, and I'll try not to run out of time. I'll try to keep things going. The reason, Krishna, can you turn off the mic? There's too much of sound from your mic. Thank you. Yeah, the reason I'm kind of hedging my bets slightly is because this particular semester has been absolutely unpredictable and terrible. So it's I mean, I'm very afraid to predict anything in this stupid year. All right, which is pretty much the reason for which I'm keeping the option open for at max one extra class, but nothing more than that. Okay, so before we took this somewhat involuntary break, I was talking about predation. No problems, no problems. So before we took this break, we were talking about predation. And in predation, the last topic that we were dealing with was prey strategies to avoid the predator. Now, what I had done was I had shown you guys one condensed video, which was discussing the various strategies. And it did a reasonable job of discussing the strategies. However, normally what I do is, even after that thing is over, I revisit the various concepts in that video, and then I kind of reinforce those lessons with a few other examples not covered in the video, and so on. The reason I do this is because many a times I have found that students have a problem with some of the concepts that are being explained in the video. So this time, since that thing is kind of already done in the class, this time that one concept wala thing, I mean repeating those concepts wala thing, that one I'll put on a video and I'll upload somewhere during the weekend. Okay, so that is what is going to finish the predation topic. Today what we'll do is we're going to start with a new topic. All right, so for starting with that new topic, we are going to, okay, let's first quickly have a chat. So have you guys heard of something called the Aral Sea? Is there anyone who knows what the Aral Sea is and why it is famous?
It's a landlocked sea in Asia, right? Central Asia, somewhere.
Kazakhstan.
Yes, it's a lake basically, and it's in Central Asia. Yes, and yes, it's drying up. Why is it drying up? Anybody has an idea? Okay. It is the fact that it is drying up. Is
it because of succession by any chance?
No, it's not succession. It's not succession. I think what Likhit has written is correct, but the scale at which this thing is happening is absolutely unprecedented. Okay, and that's pretty much what we want to start with. So just to give you guys some numbers, Aral Sea was the 4th largest lake on this planet in 1960. Its area at that time was around 68,000 square kilometers, which just to give you guys an idea, is about 142 times the area of Pune. All right. In 1960, the Soviet government decided that the agricultural production and particularly cotton production in Central Asia needs to be boosted up. So what it did was, there were two rivers that used to feed this Aral Sea. It diverted some of that water for cotton irrigation. And the result of that particular decision was rather catastrophic. So just one sec. Yeah. So can you see this screen, people? Disappearance of the Aral Sea?
Yes, we can now.
Yes, we
Yes.
can now.
Yes, sir.
Okay.
The
Yes.
disappearance of the Aral Sea in Central Asia, with Kazakhstan to the north and Uzbekistan to the south, is one of the world's greatest man-made disasters. It was once one of the 4 largest lakes in the world, but after Soviet-era irrigation projects, it's less than 1/10 of its size, and its once prosperous fishing industry is all but destroyed. In Kazakhstan, with the help of the World Bank, more than $80 million have been spent trying to save most of the northern part of the sea, but this has only benefited a few hundred people. So what's happened to all the people still living in deserted fishing ports, and will they ever see the sea again? Here are their stories.
Содан кейін теңіз уже соқта теңіз 60-шы жылдан бастап теңіз кетіп жатыр ғой, оны ешкім білген жоқ. Последний раз 1977-78 жылдары.
Аралдың жағдайын бұл кезде ешкім ойлаған жоқ. Бұл кеуіп қалада осындай катастрофа, экологический жағдайға ұшырайды бұл кезде ешкім ойлаған жоқ. Менің есімім Абылайхан, фамилиям Құлмұратов. Ол солтүстік Арал теңізі бөгетінде инженер болып жұмыс істеймін. Арал теңізінде құйып тұрған екі өзеннің суын ирригацияға есепсіз пайдалану салдарынан 1989 жылда Арал теңізі екіге бөлінді.
Ол кезде теңіз қайтып кеткен бұл жерде. 76 жылы. Теңіз кішкентай теңіз, ащы суы. Қиналдым. Мен қиналып балықтан шықтым. Балық аулап жүрген жерінде. 87 жыл. Жаңағы шөптің басы тұзданады да. Содан келіп жеген мал, соны жеген мал. Соленый деген ауруға тап болды. Ана шөптің тұздылығы көбейіп. Басы ауырады. Басы ауырып, айналып, басын жер көреді, сонымен өледі мал. Мен 15-16 мал жоғалттым. Сондай түйеден түйе ауырып өлді. Қайтып келіп жатыр, ол ана Дарияның бөгілгені. Ұлы теңіз бенен кіші теңіздің ортасындағы плотинаның бөгілгенінен әуелі мына кіші аралға су жиналды. Су жиналып тұшыды, балықтар келді. 99 жылы ол құмнан бөгілген бөгетті бұзып кетті су. Бұзғаннан кейін кетіп қалды. Сөйтті де соны Қазақстан үкіметі қолға алып, бүкіл дүниежүзілік банкпенен Қазақстан Республикасының президенті Назарбаевтың қолдауыменен шлюз салынды. Шлюз салынғалы халықтың жағдайы жақсы. кеткендерден келгендері де бар, көшіп келгендер. Менің өзім 3 үй көшіріп әкелдім. Балық аулап жатыр. Сосын ақша табады балықтан. Қазір елге свет келді 2009 жылы. Телефон келді. Соның бәрі осы теңіздің келген берекеті.
Атым Маржан. Байбол қызы. Осы Арал ауданында тудым. 1948 жылы. Аралда орыстар көп болды. Мен өзім орыс мектебінде оқыдым. Орыстардың бірге сол класста қазақпен бірге біз мектепте оқығанда бір класста 2 қазақ болатын еді. Ары кетсе 3 қазақ болады. Қалғандардың бәрі орыс, украин, белорус, армяндар болды бізде. В общем, многонациональный болды ғой. Солардың бәрі кеше Арал кеткеннен кейін барлығы да кете бастады. Барлығы өздерінің елдеріне қашып көшті. Қазір мен тұрайын қаңырап, әне заводтар тұр. Зданиялар бәрі дым жұмыс жоқ, өліп қалған кәдімгі. Мертвая тишина дейді, орысша айтқанда. Барлығы көшті. Қазір біздің Аралда қазақтар қалып отыр. Біз қайыққа барамыз. Еш жаққа бара алмаймыз. Осы жақта қаламыз. Айтып жатыр ғой жан жақтан. Сақтап қалса, сақтап қалсын, халықтың наны ғой ол деген. Мүмкін сол немереміздің немересі көре ме, оны айтып отырмын ғой.
Okay. So this is what I was talking about. In 1960s, the Soviet government decided to divert this water for irrigation. And if you want to see the scale of what happened over there in Aral Sea, then this probably is the best way to look at it. So this picture here is already 1985. Okay, it has started shrinking already quite a bit. And then in 1997, you can see that this part has completely separated from the bigger part. And this is what it was like in 2009. It was almost gone. Okay. So starting the late 90s and early 2000s, the World Bank and the Kazakh government, they tried to do something about it. And you heard some of those things, building of a sand dam and all that. And as a result of that, by 2017, there was a distinct dream that things will get much better. So you can see over here, right, that this thing which is completely dried up over here, this thing, there is quite a bit of water and looks like there is some connection over here and so on. However, in April 2018, something happened. And I have no clue what exactly happened. Okay. For some strange reason, in April 2018, this place actually looks much worse. So if you look at it, this part has completely dried up. This part over here has again, kind of started drying up badly. And this part, it's not exactly clear what the situation is over here. This blue and white thing, is it because the algal growth has gone down? We really don't know. Unfortunately, I could not find what exactly happened such that there is such a huge decline within the space of 1 year. But essentially the point is that, even if we don't concentrate on these parts, what is in these first three figures is actually very, very scary. So the Aral, it was not a very deep sea to begin with. Okay, compared to many other things, it was relatively shallow, and therefore, and it had just those two rivers that were its main source. So when the supply was cut down, the area was very huge, so there was a lot of evaporation. So obviously, after a lag, it started shrinking. Now, when that water got evaporated, then obviously the salt content of the water increased, which is what that guy was referring to in that video. And as a result of that, lots of terrible things started happening. First of all, because there was less of water and salt was increasing, therefore these guys, they had to put in more fertilizers, etc., in order to boost the crop productivity. All that went into the water. Second thing was that this area had been used by the Soviets for all kinds of weapons testings. So all those, chemicals, etc., etc., they were dumped, and also from industries, they were all being dumped in the Aral Sea. So when the water started evaporating, then all these things, they, kind of went into the surface, and from there, they started, you saw how dusty that area is, right? They basically started blowing with the wind. When that happened, if you look at what happened to the people, all kinds of diseases started increasing in that area. Respiratory illness, cancers of different kinds, different problems of the gut, kidney ailments, etc., etc. As a result of which, the average lifespan in that area started falling. Fisheries was one of the major things, that was supporting the population in that area. The commercial fisheries completely collapsed. As a result, there was mass migration. This is what that lady was referring to, that, earlier you had all kinds of people, Kazakhs, Rus, Belarusian, etc., etc. Now only the Kazakhs are left. And because of all these things, the ecological toll was absolutely, absolutely massive. So the number of fish species decreased from 32 to 6. The number of bird species almost halved from 319 to 160. The number of mammalian species also went down from 70 to 32. Okay. Now, of course, Kazakhstan and this Aral Sea is one of the biggest examples, one of the most eye-catching examples of this phenomena, whereby humans, by changing the water usage, have caused problems for water bodies. However, by no means it is the only one. It is actually a global problem, to the extent that people have predicted what oil was for this century, water is going to be for the next century. Whoever controls the source of fresh water is basically going to control the power in the world. And this, if you think about it, if you are following what happens in India, you will also know that pretty much every year, before the monsoon sets in during the summer months, there is a lot of issue about availability of water, particularly in the rural areas. And if you are aware of what happens in northern Maharashtra, Marathwada, those regions, you know that it's literally a life-death problem. Okay. So, whatever we talked about till now was in the context of human intervention. All right. Now, very interestingly, even if you leave a lake to itself, even without human intervention, even then, most lakes are going to suffer a similar fate, right? And people, can you hear me? Are people able to see the thing? Okay.
Yes.
Okay, thank you. See, since I don't have any feedback from anywhere, sometimes I just get worried that the connection might have failed and I'm just shouting away to glory to myself. Anyway, so this process is broadly known as succession, as some of you have pointed out. However, within succession, there is one particular part which is called eutrophication, which is what we are going to study in the context of this topic. Okay. So if you start with a lake which looks like this, more often than not, you actually end up getting something like this. Okay, it is very, very natural. Now, the two things that we are going to study in this class are A, why this happens, and B, how does one rectify the situation. So as I said, the main thing that we are going to talk about is eutrophication. Now, there is going to be a slight change in the way we deal with this topic, because till last year, there was a 3-month-long practical on eutrophication that all students did. Okay, this is about something called, what is the name? Vinogradski's column. All right. So all students established a Vinogradski's column and live saw this process happening in front of their own eyes. Since that is not possible this year, but you guys are at home, write down this name, Vinogradski's column, and try to see if you guys can establish a Vinogradski's column at your house. Okay, it's very simple. All you need is a bottle, and you need some, water, and you need some soil from a pond or some kind of a water body. That's about it. And if you do establish a Vinogradski's column, then a lot of things that I'm going to talk about over here, you will be able to actually see those things happening right in front of your eyes. So, classically, people think that lakes are of 3 types. Okay, so you have these lakes which are very, very clean. The water is very clear. The transparency, that is the depth up to which you can see in the lake, is very large, and there doesn't seem to be any much biological activity happening over there. Okay, there aren't too many, let's say, algae growing and so on, and that's what is meant by little productivity. So such lakes typically are called oligotrophic. Oligo means a few, trophic means related to food. So basically it means that it has less amount of food, or nutrients actually in this case. Then you have the second kind of lake, which typically derived from the oligotrophic lakes, in which the water is no longer clean. The water is more greenish in color, and that is typically because there is a lot of phytoplanktons, algae growing in that. And these lakes, they have a very high productivity, which you can measure by basically seeing the concentration of the phytoplanktons in the water. You will see that that concentration actually increases fairly rapidly. So that's the high productivity part. Such eutrophic lakes, after some time, the water becomes brown in color. From blue-green it turns brown. And if you measure the electrical conductivity of that water, you will find that it is actually pretty low. Such lakes are called dystrophic lakes, and the process by which from eutrophy they go into this state is called dystrophy. And after this, essentially the lake ceases to be, which basically means that it becomes swampy, it becomes marshy, and after some time, essentially there is no water, it becomes part of land. When there is no water in a lake, that's the stage at which you say that the lake has become extinct. Okay. Now this is the classical view, and we now know that it's not as simple as that. Not all lakes, go through these stages. Some lakes stay in the oligotrophic state for what looks like forever. Some lakes become eutrophic but don't necessarily become dystrophic. They again stay there for quite some time, and so on and so forth. So the classical view, the contemporary view of lake types is, it essentially says that there are no, there are no hard boundaries like this lake is oligotrophic, this lake is eutrophic, or this lake is dystrophic. What you have essentially is a continuum. Okay, and then within this continuum, you put in some additional criteria and say, if the values are from this range to this range, I'm going to call it this. If it is from this range to that range, I'm going to call it that, and so on. So those are more arbitrary criteria rather than the kind of hard criteria that was shown in the previous slide. So after a lot of study, people have basically figured out that when it comes to productivity of lakes, there are two things which matter the most: phosphate amount and nitrate amount. And even within them, phosphate amount is the one that matters the maximum. Therefore, the modern way of classifying lakes is simply by how much phosphate is there in the water. And you have these various classifications. If it is less than 5 microgram per liter, you call it ultra oligotrophic, 5 to 10 oligo, 10 to 30 meso, 30 to 100 eutrophic. And if it is greater than 100, you call it hypereutrophic. Okay. Now, as I said, this is a very thumb rule kind of a thing. And in reality, when you are studying the trophic condition of a lake, the phosphate concentration is just one thing. There are many other things that together determine what the trophic state of a lake is. So let's start with the problem that suppose we have a lake in our hand. Okay, let's say it's a freshly formed lake. Let's say it has been formed due to one of those, whatever, maybe due to an earthquake or due to a volcanic activity or whatever. So it's a freshly formed lake. And now this lake, obviously the water is very clean, and now the trophic status of the lake is increasing. So basically the amount of nutrients in the water will keep on increasing. So what are the various factors that you think will determine the rate at which the trophic status is changing? Can you guys say one or two things quickly?
Maybe the deposition of like whatever agricultural runoff comes.
Right. So the rate at which agricultural runoff is coming. Fine. What else?
The kind of species present in the lake.
How will that determine the trophic status of a lake?
Like there's something that like eats everything. There's some very hungry fish, suppose. I assume that would kind of prevent the buildup of other algae sort of stuff. I don't really know.
It will. No. That thing is not a cause. That is more of a consequence.
The kind of species that colonize the lake at the beginning, the pioneer species.
Correct. But most pioneer species, they have similar properties. Okay. So it doesn't really matter which pioneer species are doing it. And anyway, when a lake is freshly formed, when there are very few nutrients, the soil is not very well formed, then in any case, the number of species that can act as a pioneer species are very few. Okay. And those pioneer species are not, in terms of how they affect the trophic status, they're not too different from each other. So what you are saying theoretically makes sense, but in practice that doesn't, it's not too important a factor. Anything else?
So the total number of organisms living in a lake?
Sorry, come again?
The total number of organisms living in the lake?
Same thing. When the lake is just starting off, then the total number is going to be very low. So what you guys are talking about, these things are all going to become factors much later in the progression. Okay, they will become factors, but much later. Towards the early phase, what else will happen?
I'm thinking about partial pressures of gases, about partial pressures of gases, like
partial pressures of gases. Okay, what determines the partial pressure of gas, and why will that be important?
But because it's sort of determining organisms that come in and stuff like that. But I'm not sure. It's just something that sort of.
Yeah.
I think it would be temperature.
Okay, why temperature? In what way?
As in, if it gets too cold, then the total productivity of any organism that stays will decrease, or how this rock around it reacts to the water itself will change, so the amount of nutrients that goes into the water will change.
That's a different point altogether, but that's a valid point. The nature of the rock, the nature of the rocks around is a very important thing. Okay, if those rocks contain a lot of phosphate, then obviously when water will run over those rocks and will leach those rocks, then all that phosphate is going to come and get deposited in the lake. So that one is fine. But what you started off with was temperature. Yes, temperature is a very important factor. It will even determine the partial pressure of the gases. But temperature is important in a very basic way. What is that?
Evaporation rate.
Evaporation rate, exactly. The higher the evaporation rate, the more the same amount of nutrient will, the concentration of the nutrients will increase, right? So I'll just give you guys, I don't have too much of time today, so I'll just give you guys the major factors that are there. First and foremost, it's about the depth, because the depth determines how much of water is there, and how much of water is there is going to determine what the concentration is going to be, right? Then obviously, what is the nature of the drainage basin? What is the drainage basin? The drainage basin is the area over which the water has to flow, the rainwater, in order to reach the lake, rainwater or river water, whatever is feeding that lake. Okay, so if the nature of the rocks is such that the erosion rate is very high, then obviously the rate at which various chemicals are getting input into the lake is also going to increase. And obviously, as we talked about, it depends on the composition of the soil, because the more phosphate or the more nitrate is there in those rocks, the nutrient input will go higher. Then of course it will depend on climate. So since the major source of water in many lakes, not all, but in many lakes, is rain or snowfall, then obviously how much rain is coming in is going to determine what is the way in which the concentration, even if the nutrient concentration is increasing, how it is getting diluted. Temperature we already discussed, and as someone pointed out, it also depends on the human activity nearby. So there is a special term for that thing which is called cultural eutrophication. So basically all those sources of nutrients which are human origin and which are increasing the nutrient nutrient content of the lake, all those are called form a part of cultural eutrophication. There are two major sources here. One is fertilizers, and fertilizers, you guys can see why it is so, because the two major things, as I said, are nitrate and phosphate. And if you know that these two are also the major components of fertilizers, because these two are also the components which the plants need for growing fast. So that's the big one. And of course, human waste products, both domestic, sewage as well as domestic usage, and industrial, that also contributes in a major way towards cultural eutrophication. And again, the primary source is through phosphate. Okay, so what is the process by which the lake changes from oligotrophic to eutrophic? So this is actually what I'm showing you in this one slide is like, I don't know, probably half a semester course in limnology. There is a huge amount of chemistry involved in this whole process, not surprisingly. I'm just going to take you guys to the main steps without going into the details. So what happens is, in the first stage, you have an enrichment of nutrients, and particularly phosphorus, which can happen due to two reasons, natural and anthropogenic, as we discussed in the last slide. Now, once the phosphate amount increases, then the algal population in the lake, that goes up, and this is what is called algal blooms. Now, not all algae are equally important over here. The ones that are particularly problematic are the so-called blue-green algae, and particularly these two groups, Anabina and Microcystis. These two cause the maximum amount of problem. Now, once the algae amount goes up, then two things start happening. One, of course, is that many of these algae, they are oxygen breathing, so they end up taking oxygen from the water. And secondly, these algae, they are floating on the top of the lake, so they end up forming a mat. They end up forming an opaque layer on the top of the lake, because of which the amount of light that is penetrating towards the lower part, that goes down. Now, once that happens, then all the vegetation that is rooted vegetation, so all those plants which are rooted to the rooted to the bottom of the lake, and they are basically submerged vegetation, those guys, they need oxygen and they also need light for photosynthesis. Those guys, they get cut out. Okay, these are known as macrophytes. The macrophytes, their numbers start going down. When that happens, then again these macrophytes, they need oxygen, but during the process of photosynthesis they also release oxygen, right? So when the macrophytes go down, then the amount of oxygen falls down even further, particularly in the lower part of the pond, which is what is known as hypolimnia. Once that happens, then the hypolimnion becomes anoxic. Okay, and when the hypolimnion becomes anoxic, then a different set of chemical reactions start involving the soil at the bottom, right? And at the same time, remember, there is a high productivity of the algae. Many of these algae are also dying. These guys are also going down. These guys are also become substrate on which these anoxic reactions start. Because of all these, there is a huge amount of phosphorus that gets leached out from the soil layer, and this essentially acts like a feed forward loop. So this is the reason for which, even though the algal population is very high, even though they are consuming a lot of phosphorus, even then phosphorus doesn't become limiting for them, because they keep on getting the phosphorus from below, from the soil, and therefore their population keeps on growing exponentially. As a result of all these things, the pH of the water also changes, and finally all the fishes and the various other aquatic life forms that are there, they start dying. So what used to be like this, clean water, this is the state of eutrophication when you see the algal blooms over here, and finally this is the stage at which the fishes basically they die en masse. Now this process, this formation of this is the state at which you essentially call the lake to have become eutrophic. Now lots of people say that this is primarily a problem of small lakes, because after all it's only in small lakes the concentration of phosphorus will become very high. If the lake is large, it will not be a problem. However, just to show you guys that that is not the case, what I am showing you over here is the Caspian Sea. And if you know what the Caspian Sea is, it is the largest inland lake in the world. Okay, it's larger than many countries, let's put it that way. And if you can you see this over here on the north part? This is eutrophication happening, and I think you can see the same over here too. Okay, so this is just to show that this problem can happen even when the lakes are very, very large. So obviously this is a very big issue, and it has very severe commercial repercussions. More importantly, it has got very, very serious other kinds of repercussions. Basically quality of life goes down. People have to migrate if the water body feeding them fails. Therefore, a lot of work, a lot of thought process has gone into how to reverse the process of eutrophication, and that is what we are going to study in the next class. Okay?
Sir.
Just one sec. So it's 45 already. What I'll do is I'll stop the recording So the class is officially dissolved. Good, it is coming to my Google.